Welcome back to the video series of measurement and instrumentation. So in this lesson we are currently having a video series of unit 1 of the measurements and instrumentations, which is measurement of voltage and current. So in last video we have seen what is mean by measurement, what are the base, why we are in a need to study measurement and instrumentations. So we just had a brush up of the introduction to measurement and instrumentation. In this video we will be discussing about the methods of measurements. As we have already discussed, measurement is an act of giving a physical value to every quantity. So in general, there are two methods for performing the measurements. One is the direct method and the other one is the indirect method. Direct and indirect measurements are commonly used everywhere in order to give a physical representation to any quantities. With direct measurements, the measuring instruments such as vernier calipers, micrometers, and like scale. So these measuring machines are used to measure the dimensions of the target directly. So direct methods involve the direct measurement of any unknown quantity. So as the name implies, that gives the answer itself. So direct measurements are measuring an unknown quantity directly. So in this method, the value of the quantity is obtained directly by comparing the unknown with the standard. So these methods compare the unknown quantity measurand, which is the unknown quantity, directly towards a standard. As discussed already in the examples in a previous video, if I am drawing an unknown line, that is the measurand for which the length is to be measured. So for that unknown line, I am directly measuring the measurand, which is the unknown line, against a standard, which is the scale. So which is a good example for direct method. So direct methods are common for measurement of physical quantities such as length, mass, and time. It involves no mathematical calculations to arrive the results. For example, measurement of length by a graduated scale. So as we discussed now, this method is not very accurate actually, because it depends on human insensitiveness in making judgment. For example, if I want to measure the unknown length of a line against the standard, which is a scale, if I take the reading in a wrong manner, then the measurement will be a wrong one. So the measurement is not accurate. It is because of the human error. So due to human insensitiveness, the direct methods face a drawback. When coming to the indirect methods have several parameters that can be easily measured, and the value is determined by some mathematical relationship. So direct methods involves no mathematical relationships or comparisons or any manipulations with the data, whereas indirect method deals with the manipulation of data. For example, if we want to measure the density by measuring mass and geometrical dimensions, that is a good example for indirect method. So measurements by direct methods are always not possible, feasible, and practical. As we discussed the drawback right now, in engineering applications, measuring systems are used which require a need of indirect method for measurement purposes. So we are in a need to use indirect methods for measurement purpose because it yields more precise answers. The need for indirect method arises because over a wide range of quantity to be measured, there is a chance that the measurement will go wrong due to erroneous readings of the scales. Hence, we are going for indirect methods. Due to the drawbacks or the readings of the scale in the direct method, we are going for the indirect method. With the indirect measurements, the dimensions are measured using measuring instruments such as dialed gauge that look at a difference between target and reference device such as gauge blocks and ring gauges. So these are also known as comparative measurements. So the indirect method of measurement is also called as comparative measurements because due to the fact that a comparison is performed using an object with the standard dimensions. The more predetermined definitions is that the shape and dimension of a reference device are, the easier the measurement becomes. So if we have a comparison device which has the same shape and dimension as that of the unknown device, then the comparison will be very easier and the measurement becomes easier as well. But the disadvantage is that the measurement range is being limited. So let's see the difference of direct measurement and indirect measurement with this example. So here, as discussed earlier, the measurement is being done for an unknown length using a scale. So let A be the target for which I need to measure its length. So if I'm using a direct measurement, then I can easily measure the length of A, the target, using a measuring scale. So there is no manipulation of data, there is no conversions or comparisons. Hence I can yield the output very easily. So which is nothing but the direct measurement. Whereas in indirect measurement, I have a reference gauge, which is the block B, which has the same dimension and shape as that of A, and the values of or the parameters of B is already compared against the standard and the values are noted. So to get the value for the target A, I am comparing it with the reference gauge B. So instead of directly comparing with the standard, I am comparing with a reference device, and then I am getting the or extracting the measurements, which is the example for indirect measurements. Now let's see why we need these measuring systems. Measurement involves the use of instruments as a physical means of determining quantities or variables. So for example, if I'm doing a direct measurement, I need a certain type of instrument to measure these quantities, or you can say a variable. But in general, we don't have in olden days we don't have instruments for all these quantities to be measured, but due to the advancement in technologies and being a measurement as a one of the key feature of any quantity, it becomes a mandatory to have a measuring instrument for all the quantities. So because of the modular nature of the elements within it, it is common to refer the measuring instrument as measuring system. So in general, we don't call it as a measuring instrument, we have a measuring system, because there is a systematic approach in designing or developing these measuring instruments. Hence we are calling it as measuring systems instead of calling it as measuring instruments. So in this video we have discussed what are the methods of measurements we have and what is meant by measuring instruments. In the upcoming video, I will meet you with the continuation of this topic. Hope you find this video very useful. We'll meet you in the next class. Thank you.